Hello everyone, welcome back to my channel. So today's video topic is real numbers decimal expansion. It is again a topic of grade 9th. As in my previous video I told you about what are rational numbers, what are irrational numbers, what are real numbers and so on. So as you all know, what are real numbers? Real numbers comprises of all the rational and irrational numbers as well. And what are rational numbers? Rational number means the numbers which can be written in the form of p by q, where q can never be equal to 0. And irrational number, the numbers which cannot be written in the form of p by q are known as irrational numbers. Okay, this means real number comprises both rational as well as irrational. Now in this video we will learn about their decimal expansion. Okay, this means when a rational number is given or when a real number is given, then how to convert them in decimal numbers and what we call to those decimal expressions. Means in this video we will learn about basically these two terms, terminating decimal numbers and non-terminating decimal numbers. Then again about non-terminating recurring or repeating decimal numbers or non-terminating non-recurring decimals. Now let's learn about this in detail. So every real number will always be, whenever we just convert the real number in decimal expression, that time it will either be terminating or non-terminating. Okay, so just remember these two terms, terminating and non-terminating. Then again, non-terminating can further be divided in these two categories: non-terminating recurring decimal numbers or non-terminating non-recurring decimal numbers. Terminating means when we divide a fraction, suppose a fraction is given, when we divide the fraction or when we convert it in decimal form, then if our division ends after a certain point or we got the remainder as 0, or our division ends, terminates means ends, if it ends at a certain point, then in that case our decimal number will be terminating decimal number. For example, let's take a fraction, suppose 1 by 2, very small fraction I am taking, 1 by 2, when we convert 1 by 2 in decimal form, then it will be nothing but it will be 0.5. This means our division is getting ended. After a decimal point we have only one digit, we have finite number of digits, it is getting ended. That's why it is known as terminating decimal number. You can take any other example. Now let's take 1 by 4. So 1 by 4, let's divide it. 0.4 2s are 8 and 5. So in this case we will get 0.25. It is again a terminating decimal number. Again our decimal is getting ended after a certain point, after certain steps. Okay. Now after this, we can take, for example, 7 upon 8. 7 upon 8 means we are dividing 7 by 8. So let's divide. Okay. Put a decimal and write 0 here. Now 8 8s are 64. Let's subtract. We will get 6. We can put 0. Then 8 7s are 56. And this is 4. So put 0. 8 5s are 40. So this means again we are getting remainder as 0. Here remainder is 0. This means this is again a terminating decimal number. 0.875 we got this. So here in this case our division is ending after 3 decimal numbers. After the decimal point there are only 3 decimal numbers. Okay, hence it is a terminating decimal number. So what were the examples we did? 1 by 2, 1 by 4. This is 7 by 8. Similarly, we can do 5 upon 4. So what we will get? So let's do here only. 5 upon 4 will be 4 ones are 4. Okay. We left with 1. So 1 0, 4 2s are 8. And 10 minus 8 is 2. So 4 5s are 20. So we will get 1.25. When we convert this fraction 5 upon 4 in decimal expansion in decimal, when we do the decimal representation of this fraction, in this case we are getting 1.25. So this is again a terminating decimal number. Okay, 1 by 2 we already did, 0.5. Let's do this one, 33 upon 8. Means here we have to divide 33 by 8. So 8 4s are 32. 3 minus 2 is 1. Okay, we can put the decimal and we can put 0. 8 ones are 8. This is 2. So we can again put 0. 8 2s are 16. Now we get 4 and we can put 0. 8 5s are 40. So this means again our remainder is 0 after certain steps. And we got 4.125. So it is a terminating decimal number. So terminating decimal number means when the decimal expansion of a given real number of a given fraction ends after a certain steps, ends after a certain time, or it has finite number of digits after the decimal point. In that case, it is known as terminating decimal number. So remember this, by this word terminates means comes to an end or the end of something. Okay. Now let's take non-terminating. So as it is clear by this word non, means when the decimal expansion of a number of a fraction is not ending after a certain steps, it will go on and on infinitely. Okay, the numbers will never end. So in that case, it is known as non-terminating decimal numbers. We will do few examples, then only you will get to know about this term. Okay. Then again, this non-terminating can further be divided in two parts. So this one is non-terminating recurring repeating decimal. What do you mean by recurring? Recurring means repeating. Means when in a division few certain one digit or a group of digits are getting repeated again and again, in that case it is known as non-terminating repeating decimal numbers. And when after dividing it is not ending or not any a single digit is getting repeated, in that case it is known as non-terminating non-recurring decimal numbers. So our all the terminating decimal numbers will be rational numbers. Okay. And non-terminating repeating decimal numbers will again be rational numbers. Only these non-terminating non-recurring decimal numbers will be irrational numbers. Okay. Now I will tell you why. So first let me just take you to this one, to this term. Now non-terminating, for example, let's divide 2 upon 11. Okay, so it is a fraction given 2 upon 11. So we need to divide 2 by 11. So what we will do at the first step, we will put 0, we will put decimal, and we can put 0 here. Okay, 11 ones are 11. Let's subtract. What we will get? We will get 9 here. Okay, now let's put 0. So 11 8s are 88. Then subtract, we will get 2. So again we can put 0. 11 ones are 11. And then subtract. And then we will left with 9. So again 11 8s are 88. And the same steps will repeat again and again. Means in the quotient we will get the, see what is the quotient here, 0.18, 18, 18, 18 and so on. It is not ending. So hence these numbers are known as non-terminating decimal numbers. But you can see a pattern here. Here after the decimal point, these two digits 18 are getting repeated again and again, 0.18, 18 and 18, 18. So we can write it as 0.18. We can put a bar over the digits which are getting repeated again and again. Instead of writing like this and putting this dash dash dash, we can write like this. This bar represents that these number of digits are getting repeated in this decimal expansion. Okay. So what kind of number it is? It is non-terminating repeating decimal numbers. Okay. Let's take another example. It is 11 upon 9. So again, let's divide 11 by 9. Our numerator is 11. It will come inside. So 9 ones are 9. 11 minus 9 is 2. Okay, we can put 0. Put the decimal and then put the 0. 9 twos are 18. Again we will get 2. So it was 9 ones are 9. We get 2. Then 20. 9 twos are 18. 20 minus 18 is 2. Now again we will put 0. Again 9 twos are 18. And we will get this again and again. Again we will put 0, then 18, and this will continue till infinite number of steps. So here we will get, what is our quotient here? 1.2222222 and so on. So here what we can do, instead of writing 2 so many times, we can just put a bar above 2 because only this digit is getting repeated. Okay. Now similarly we can do for 50 upon 7. So let's do for 50 upon 7. So we can do here. Okay. 7 sevens are 49. So we left with 1 and put a decimal and put 0. 7 ones are 7. We will get 3 and put 0. 7 fours are 28. Write 2 and then 0. 7 twos are 14. 20 minus 14 is 6. Write 0. 7 eights are 56. So again 60 minus 56 is 4. Put 0. 7 fives are 35. 40 minus 35 is 5. Put 0. Then again 7 sevens are 49 minus 1. Then again we can put 0. Now after this point, this process will start repeating. These digits will start repeating. 1, 4, 4, 2, 8, 5, 7. Okay, what is the quotient here? 7.142857. If we will further divide it, we will get the same number of digits again and again. So instead of dividing, so you can just do one more step. 7 ones are 7 to cross check. So we left with 3. So again we are getting the same thing. Okay, so our quotient in this case, it will be 7.142857. Means these number of digits are getting repeated. So we will put the bar over these all number of digits. So in this case, it will be 7.142857 bar or 7.142857, again 142857 and so on. So it is again a non-terminating and but recurring decimal number. Okay. So I hope you understood the meaning of terminating and non-terminating. Okay. Terminating means whenever division ends after a certain point, then that is known as terminating decimal numbers. Non-terminating whenever division does not end, it go on and on infinitely till infinite number of steps. That is known as non-terminating. In non-terminating, when certain digits repeats itself again and again, that is known as non-terminating repeating decimal numbers. Now what are non-terminating, non-repeating decimal numbers? When in a division any digit will not repeat itself. Okay. For example, the value of root 2 is 1.41421356237309 and so on. So you can see in these the digits are not making any pattern, not any digits are getting repeated again and again. So that cannot be converted in a rational number. Hence root 2 is an irrational number. Similarly, the value of root 3 is 1.73205080 and so on. Again, here it's a non-terminating, non-repeating decimal numbers. Hence, it is again a irrational number. If you will take root 4, the value of root 4 will be 2. Okay, and 2 can be written in the form of p by q. So it will be our rational number. It will not be rational number. If we take root 5, again root 5 will be our irrational number. It is again cannot be written in the form of p by q. Then root 6, root 7 and so on. Okay. Even pi is also an irrational number. The value of pi is 3.14159265358979 and so on. So it is again never ending and it is non-repeating also. Hence pi is an irrational number. But sometimes if you take the value of pi is 22 by 7, which is not exactly 22 by 7, the value of pi is not 22 by 7. But if it is given that whether 22 by 7 is rational or irrational, in that case you need to check, because it is clear pi is an irrational number. But if it is given in the fractional form, if the value is given 22 by 7, in this case 22 by 7, let's divide it. 7 3s are 21. We got 1 here. Put the 0, put the decimal after this and put 0. 7 1s are 7. 3. 7 3s are 21. 7 4s are 28. Then 2. Then again 7 2s are 14. 20 minus 14 is 6. Then 7 8s are 56. So 60 minus 56 is 4. Then 7 5s are 35. Then we left with 5. 40 minus 35 is 5. We put 0 here. And 7 6 are 42. 7 7s are 49. Then again we left with 1. Now again these steps will get repeated. If we will further divide it, we will again got this 10. And these all the digits will get repeated. So in this case, we got the quotient as 3.142857 bar. This means it is a rational number. It can be converted in the form of p by q. How we convert these kind of non-terminating repeating decimal numbers into a fraction in the form of p by q, that I will discuss in another video. Okay, but just make this point clear that 22 by 7 is a rational number. Okay, but pi, I am writing the complete, but pi is an irrational number. Okay, because the value of pi is this much. It is not limited till 3.14. Okay, sometime in questions it is given, it will be given that take the value 3.14 or take the value 22 by 7 for our convenience. That time we will take these values. But if it comes that from 22 by 7 and from pi, which one is rational and which one is irrational? In that case 22 by 7 is a rational number and pi is an irrational number. Okay, this means the rational number, the real numbers have only two choices. It will either be terminating or be non-terminating. Then again, non-terminating have only two choices. It will either be repeating decimals or non-repeating. So these all the numbers, these all the terminating decimal numbers will be our rational numbers. These all the non-terminating recurring repeating numbers will always be our rational numbers. Only these numbers, the numbers which fall in this category, non-terminating, non-repeating decimal, that will always be irrational numbers. Okay, so in our next video we will focus on this point, that how we can convert non-terminating repeating decimal numbers into rational number. Okay, so till that time just revise this topic and I will get back to you in my next video. Till then, goodbye. Take care. Thanks for watching.